The last situation is if in our function, in our integrand, we possibly have a vertical asymptote, then you know the integrand itself could be approaching infinity. So even though our limits look like perfectly, good numbers, if we look at the function that we have 1 over the square root of 1 minus x, obviously we have a vertical asymptote at x is equal to 1. So something's going on here. So I can't just plug in a 1. So what I'm going to do is what I always do. So I'm going to just rewrite this as the limit as b approaches 1 now. And I can go between 0 and b of 1 over root 1 minus x dx. And I'm going to use u substitution for this. So u then is 1 minus x. du is negative dx, so I just need negative du is dx. So I'm just going to take the antiderivative of negative u to the negative 1/2 du, which is going to give me negative, and this is going to give me u to the positive 1/2, and the reciprocal of that is 2. So I end up with negative 2, and I'm going to have 1 minus x to the 1/2. And then, as before, I'm taking the limit as b approaches 1. My limits of integration are 0 to b. And let's just move that a little bit. So then I end up with the limit as b approaches 1. I'm going to keep that 2 outside. I have 1 minus b to the 1/2 minus 1 minus 0 to the 1/2. And now this is perfectly doable. As b approaches 1, well, this thing is just going to give us 0. And this is just going to give us 1 minus 0 is just 1. Square root of 1 is just 1. Oops, so we end up with negative 2 times negative 1. So that integral, in fact, converges. The integral we started with converges, and it converges to 2. Here's another situation. Another situation might be that you have something that doesn't have an asymptote at the end point, but you know there's an asymptote somewhere lurking inside. So suppose our integral goes between 0 and 3. We have 1 over, let's say, x minus 2 to the 2/3. And we need to be really careful here, because if we're not on our toes, we're just going to take the antiderivative and we're going to get something that could potentially be wrong. We know that this function has an asymptote at x is equal to 2, so this is a situation where I'm going to have to split this up. 0 to 2, and I'm going to just write this as x minus 2 to the negative 2/3 plus 2 to 3 of x minus 2 to the negative 2/3. And then I'm just going to take this bit by bit. So for the first one, I'm taking the limit as b approaches 0 of b to 2, x minus 2 to the negative 2/3 dx. And I'm just going to rewrite that as take the antiderivative, so the limit as b approaches 0. And this is just going to give us, it's really u substitution, but let's not be bothered. We know we're going to get x minus 2, and if we add 1, that's going to give us to the 1/3, 3. And we're going between b and 2. So the limit as b approaches 0 of, well, let's see, if we plug in a 2, that's going to give us a 0. And if we plug in a b, it's just going to be 3 times the cube root of b minus 2. And as b approaches 0, it's a cube root, so this is quite all right. So this is just going to give us negative 3 times the cube root of negative 2. Let's also work on the other piece of this. We're going to also look for the limit oh shoot